Hi, welcome to this tutorial video. This is Frederick from Detroit, Berlin, a channel about modular synthesizers and music gear in general. This episode is going to be pretty basic, aimed towards beginners and people who want to discover what a modular synth is all about, because I'm going to talk about the A-110-1 from Doepfer, the standard VCO. A VCO, like the standard VCO from Doepfer, is a sound source. It generates waveforms and that makes a continuous sound. And when it's voltage controlled, that means that the pitch of that sound is controllable via control voltage. So with sending voltages to the VCO, you control the pitch, and when it tracks at 1 volt per octave, that means that if you add 1 volt, you play exactly 1 octave higher. If you add 2 volts, that means 2 octaves higher, etc. Let's take a look at the standard VCO and how it actually works in a modular synthesizer. A basic audio path in a modular synthesizer: you have the VCO, the sound generator. Then if you want to combine it with a second VCO or another sound source, you send those signals to a mixer, you mix it. You might want to filter it with a filter. Then you send it to the VCA, the voltage controlled amplifier, which is like a door that is closed. And sound generation, it's continuous signal, and when you feed it voltage, it opens the door and the sound gets put out to the output. And how do you open that door? It's mostly with an ADSR envelope generator. It's an attack, decay, sustain and release envelope generator, which receives a gate signal. An ADSR will act upon this signal. It will open, it will close. This is the attack and the decay stage. And then with the sustain, when you keep the key pressed, the sustain is a level of voltage that it will keep on sending until you release the key, and then the release will kick in, and it's the tail of the voltage, and it will slowly fade away, or it will quickly fade away if the release time is very short. This ADSR signal can also open and close a filter. That is kind of a really basic chain in modular synthesis. And let's take a brief look at the standard VCO. I made a little sequence. I will scroll through all the waveforms of this standard VCO to give you an impression of how all those waveforms sound. And then we will go over the controls of the oscillator, and you can download the notes of this simple patch over on my Patreon, so please check that out. Don't forget to give this video a like and subscribe if you haven't already. Next episode I will show 5 easy ways to supercharge your oscillator with the use of pretty cheap and simple modules. Combine it with the oscillator and then have a really interesting outcome. So please subscribe if you want to be notified when that episode airs. Let's play the sequence. We start at the right. Here we have the sine wave, which is a very round waveform. Like it's depicted, it's like a really round wave, like an ocean wave. It's going really smooth, and you can hear that it is pretty damped, almost sounding. It's sounding pretty damped. If we go higher pitch wise, then it's very soft, it's very round. Like you can see on the oscilloscope is actually showing the waveform. So if we stop the sequence and let's open the VCA totally so we can hear the note play. You have the waveform, it's really smooth, it sounds round, and that's very nice. That's a sine wave, it lacks harmonics, and because it lacks harmonics, it sounds really pure, really simple. If we take a waveform with a few more harmonics, then we can go to the triangular waveform. It's like a sine wave, but it has a straight slope up and down. It's a little bit pointy and you can hear that. It has this buzz. It sounds buzzier than the sine wave. It has a sharper sound to it. And if you can see on the oscilloscope, it's pretty triangular. Let's play the sequence. So we close the VCA and we play the sequence again. And it has more overtones. Has a little bit more punch to it. So that is the triangular wave. Let's stop the sequence and go over to maybe the saw wave. And the saw wave, it's a waveform that goes straight up and then a downward slope that is pretty straight. It sounds even more buzzy. It really sounds sharp like a saw. It buzzes. Let's maybe go up a few octaves. And you see on the oscilloscope, it goes straight up and then it takes a 90-degree down angle. Play the sequence again. And it has a different timbre to it. It has more harmonics, and the way these harmonics are positioned, it makes the sound saw. And then we've got the square waveform, and with the standard VCO, this square waveform has pulse width control, and that means that if you have a square with no pulse width control, then the part that is positive and the part that is negative has the same width. If you have pulse width control, you can make the positive longer or narrower, and when you make the positive longer, you actually make the negative shorter, and you can do this until you just got like a little spike, or even that you only get a negative or a positive signal, because an oscillator, it is actually an upward and downward going positive negative voltage at audio rate, and that makes it make sound. If you have a low frequency oscillator, that is like an oscillator, but it runs so slow that you can't hear it. It only generates really slowly up and downwards going voltage. So it's actually the same, but it's going slow, and an oscillator, a voltage controlled oscillator that is going into audio rate, you can use it as a sound source. When you have pulse width control and you move the pulse width control all the way and the oscillator allows it, like the standard VCO, then you can create a negative voltage or a continuous positive voltage. When you do that, then also the sound will disappear. So let's play the sequence and let's play with the pulse width. It gets more brittle. Until it disappears. Now it's a steady voltage, and it's not going up and down, so it's just a steady voltage, it's doing nothing. And then it comes back, go all the way, the sound changes. And the sound is gone because it's all the way to the negative and it just outputs a negative voltage until you bring it back and then you got sound again. Let's zoom out on the oscilloscope and let's pause the patch. So here you can see how it's actually moving, and then it disappears and then it's moving again. Let's go up in pitch. Every time you go up 1 octave higher, the waveform is becoming twice as narrow. You can do this with the range control of the VCO. Let's first go over the controls. You got inputs, you got outputs, and you got knobs on the module, and you can control them by hand, but you can also control those parameters by inputting control voltage signals coming from an LFO or from a keyboard or from any other voltage generator. Let's start with the inputs. So at the top we got the sync input. When you feed it a signal, every time when that signal triggers, or if you feed it an oscillator, every time that oscillator is going into the positive, it will kind of reset the waveform, and that makes it get a totally different sound. And it's one way to expand your oscillator sound, and not all oscillators have this sync input, but the standard VCO does have that sync input. Then you got the CV1 input, and the CV1 input is an input where you send the pitch control to, so that the oscillator will follow the pitch you input in the module. So if you play it with a keyboard, you take the control voltage of the keyboard out and you put it in the control voltage 1 input, and that will control the tuning of the oscillator, that will control it, and then you can play a melody. CV input 2, control voltage input 2, is kind of the same, but this one has an attenuator. When you turn an attenuator all the way up, it passes through the signal for like 100%. If you turn it all the way down, it doesn't pass through the signal anymore, then it's at 0%, and yeah, everything in between. So you can use that in a way that you send sequence to the CV1 in, that plays a melody, you send an LFO to the control voltage 2 in, you turn the attenuator almost all the way down, and then it slowly or quickly modulates the pitch in a gentle way. If you turn it all the way up, then it is not gentle anymore, then it really fluctuates the pitch. If we go one lower, we have pulse width control voltage 1, and it controls the pulse width. It has no attenuation. The pulse width input control voltage 2, it does have attenuation, and it's actually the same principle as the tune. It attenuates the pulse width control voltage coming in, so at 100% it passes through the incoming signal, whether it be an LFO or some kind of other signal. It passes it through 100%. When you turn it down, it goes up to 0%, and that way you can control how much you affect the pulse width. Then we got the outputs, which is the saw wave output. This is a pulse output. The pulse width control, when you put it all the way in the middle, it is a square wave. If you put it more to the left or to the right, then it becomes a pulse. The triangular waveform, and you have the sine wave. So it has 4 waveform outputs. You can mix those outputs, you can combine them to create different kind of sound combinations. Let's go over the knobs. You've got the range knob, and this has quite a few octaves that you can tune to. You got the tune knob, which is kind of a more fine control over the pitch of the oscillator. So you tune it to a certain note, and then when you play a 1 volt per octave keyboard, sending control voltage to the module, it will track that control voltage coming in and it will play the melody you are playing. Then you got the attenuator for the CV2 that controls the tune. Then you got the pulse width, which controls the width of the pulse. It's pretty self-explanatory. Then you got the pulse width CV2, an attenuator for the incoming signal, so you can attenuate it. And that's pretty much it. Let's do a demonstration on the sync and build a sound from scratch. I have the Moog Matriarch, which has a sequencer. Sequencer is sending a control voltage that is 1 volt per octave that I'm inserting in the CV1 input. This is controlling the pitch. I'm putting the LFO in control voltage 2, and for now I'm closing that attenuator. Then I've got the waveform outputs, and I will select, let's select the square. It's in the middle, so it's pretty much a square. Let's use a sequencer to send a signal to the ADSR, which will open the VCA, passing through the oscillator sound. So let's do that. Let's play the sequence. We can change which octave it's playing. Then it goes really low, and then it almost becomes a low frequency oscillator. Let's leave it here. Let's have a shorter decay or a longer decay. Shorter decay, and it becomes staccato. Okay. Then maybe let's control this pulse width also with an LFO. So let's take another patch cable and let's take the LFO and input it here. Then it's controlling it by 100%. We don't have any attenuation on this CV1 input for the pulse width, but we do have it on the CV2 input. So when we increase that, then it passes through the control from the LFO to the pulse width control. And what this actually does, it's like automating the movement of the knob by a control of voltage. Let's speed up that LFO. Let's speed up that LFO. And we can increase it, and then it goes higher and lower. And when we decrease it, it becomes more subtle. We had an LFO going into the CV2 control of the pitch. Let's turn this up. The LFO is going pretty slow, so it's like making this C6 sound. The pitch is going up and down, and let's increase the speed of this LFO. And let's attenuate it a little bit more so that it's much more subtle and it creates a livelier sound. So we have multiple controls. So that's pretty nice. And we can of course tune this pitch. So that is a pretty basic way of controlling the sound of your synthesizer, your modular synthesizer, your oscillator sound. You're controlling it in different kind of ways. Let's try to sync the oscillator to another oscillator, controlling the pitch, controlling the range. If thing that has a nice buzz to it, that square wave, you can control the pulse width. Okay, let's bring in the modulation for the pitch. Let's maybe slow it down. Makes it a little bit less stable. It's going up and down, but by a really small amount. You can hear it rise and fall really slowly. A little bit like vibrato kind of effect. So this is the oscillator, the low frequency oscillator impacting the pulse width. Which is a really nice effect. Now let's try to sync it. And we have another oscillator. Let's try another waveform. It's nicer when you do it on a low harmonic waveform like a sine wave or triangular wave. Can do it with different kind of waveforms. And the oscillator will follow the other oscillator, and you can change the pitch and it will create a nice effect. It will still be the same pitch, but timbre it will change because it's reset at the oscillator, the other oscillator's pitch. That's really nice. And if you make subtle movements, or let's maybe modulate it. That's a good use of an LFO that's changing the pitch. That's that sync sound. It's a sound that is used really often, and it's a little bit more aggressive, but it punches through a mix. You can play with the speed of the LFO. So it's creating all these wonderful sounds. Let's add a little bit of analog delay, which really makes everything sound so much better. So this is sounding really nice. I'm not filtering the sound in any way. It's the pure oscillator sound, which is now synced to another oscillator. It's an awesome oscillator module from Doepfer. Let's filter it. Which is also really nice, and a filter has so much impact on the sound, but that's for another episode. So that's about it. I will put these patch notes on my Patreon page. I will show you this patch, the modulation from the oscillator, modulating the tune, modulating the pulse width control using the second oscillator, and I will also make a patch of a really basic way of putting a modular synthesizer together with an ADSR, an oscillator, a mixer, a VCA, and I hope that makes a beginning modular enthusiast understand more of modular synthesis. And don't forget, next episode I'm going to show you 5 different ways to expand upon your oscillator and make it really do things you would not imagine are possible with really simple modules. Please subscribe to the channel if you want to be notified. Please give this video a like, support me on Patreon, and hope to see you next time. Bye bye.